In this video, you'll learn how to perform tolerance analysis using a collaborative workflow between Solid Edge and NX VSA. With Pack and Go inside Solid Edge and Siemens connector, the design can easily be uploaded to Teamcenter Share. With the full Teamcenter Share integration inside Solid Edge, the design can be opened right from Solid Edge. Solid Edge includes a powerful set of capabilities that improve the communication of manufacturing information using PMI. With product manufacturing information tools, the digital twin can be completely documented with all necessary dimensions, tolerances, and geometric characteristics necessary to build quality products. Much as we see here with this Bernina sewing machine design in Solid Edge, and we would like to use the seamless interoperability between Solid Edge and NX to leverage advanced manufacturing and simulations capabilities such as tolerance analysis in NX VSA. The design can be quickly shared with our colleagues using NX with Teamcenter Share with various permission levels such as owner in this case. Tasks can easily be assigned inside Teamcenter Share to track the progress of the project and viewed in various ways such as this Kanban board. With NX, we can quickly open the Solid Edge data shared with us and use VSA tolerance analysis to look at the plushness variation between the access door and the body of the sewing machine. But before we get into the analysis, let's look at the PMI that's been assigned to some of the parts by opening them. As you can see, this has all come through automatically, even though the assembly was originally authored in Solid Edge. Also, the dimensions and annotations are all associated to the correct geometry and the faces in the model, which is important for tolerance analysis in VSA. So, we're all good from that point of view. Next, we'll create a parent assembly and go into VSA to take a look at the structure in the Process Navigator. Here we can see the components and the features that have been created based on the extracted PMI and reference geometry. Here features can be planes, holes, pins, slots, tabs, and more. They are automatically extracted in VSA. As you highlight a feature in the Navigator, the geometry associated with that feature also highlights. Let's switch over to a fully completed analysis and have a look at an assembly operation. An assembly operation is what we use to assemble the parts together, just like they're going to be assembled in the factory. For this example, we'll look at the assembly operation associated with this access door. There are 4 features here: 2 hole alignments on either side, a slot tab alignment to position the door in the X direction, and then finally a rotational stop. You see those features highlighted in blue and red. So we have an assembly operation created for each component. Now we'll take a look at a measurement operation with this plushness measurement between the 2 points on the corner of the access door and body. Here, spec limits of plus or minus ½ millimeter have been defined. And with that, we're ready to run the simulations. In this case, it will be a set of 5,000 simulated builds along with a separate set of contributor simulations to determine the contributors to variation. The results are shown here in a thumbnail. We can see we have the normal standard deviation and the estimated range of % out of spec. The process report shows a great deal more information, and we can see 5,000 simulated builds, again showing nominal, mean, standard deviation values, variation range, and % out of spec. In the contributor report, we'll see a list of the features that are contributing to the variation, ranked from highest to lowest, and as you select a feature in the contributor list, its geometry highlights on the 3D geometry. From here, we could easily make PMI changes, make changes to the assembly operation, and redo the analysis if desired. With interoperability between NX and Solid Edge, it has never been easier to perform tolerance analysis on your designs.